Okay, hello everyone. So today we will try to resolve exercise 238 product of array except selves. Okay, before jumping into it, I would like to tell you something. Definition. Sum of now 5 and 3 is 8. The product of 5 and 3 is 15. Is times the difference between 5 and 3 is 2 minus the quotient of 6 and 2 is 3 divide. Okay, we will read one time the requirements. Given an integral array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. Okay, I will not read all the requirements because you can read it easy. Okay, what's like next? Okay, this one I try to write down the requirements by my own words. Input, we have an array of number. Output, we also have an array of number. However, we need to understand that the elements of the answer array will have equal to product of previous and after the I except I. Write an algorithm that's run in ON without using the division operation. Okay, the flow. The flow, I think it is the simplest way is we get the product of all elements in the array divide the index. So what does it mean? It means, for example, you have A, B, C, D. So to array I, answer I equal A, B, C, D. Answer 0 equal B cell C cell D. So I divide I. But we cannot use this one because in the requirements they mention that. Okay, next. So how can we do it another way? Another way we will have the left I and right I. So what does it mean? Let me explain. For example, we have a C. Okay, let me add more C. So if we want to take the answer C equal A, B is on the left times C, D, and E. That's it. Example. So how can we resolve? So look at my own words. You can see we need to take the left and the right, and then we just use their product. Yes. Okay, so what we have to do? Declare a empty array with the same number of array based on the input array. So we will, I think it should be 3 because we need to have the same with the answer. Calculate wrap on the left of array a loop. Okay. Why I told you is similar to sliding sum because it's the same when we have to sliding sum using plus, but for this one we will use times. Yes, I will explain it later when we jump into the riff song. Okay, let's do it. First I will declare, I will take the constant n equal num.length. What is it? What is next? Let me see. What do we have? Constant. Fix equal. We will have num equal new array num. Let me see. Okay, we need this one, not username. Okay, perfect. So that means we will have for example, we have ABC equal ABCD E. So that means we will have a empty one. Okay, perfect. So the same we will have a surface, we will have answers. Perfect. Okay, now we need to calculate from the left of array I. What do we have? So for the first item, it's the same. So by sliding sum, we need to declare and count from the beginning array. I mean, it should be index 0. So what do we have left? Is 0. No, equal 1 because any number num times 1 equal num. Okay, because on the left of the first number index 0 we don't have any number. Perfect. So for let I equal 1, I smaller than n, I plus plus. Perfect. So we will have a prefix I equal prefix I plus 1 times prefix 1 I plus 1. No, I. Okay, it is about I will try to explain this one because we can think place is an array has the same box like original array. So we have calculate prefix to calculate the product on the left hand of array of number I, index I, and then when for the first, as we have only for the very beginning is always a number 1, as you know, for the first element ABC, no number before A. Okay, next we will calculate. Why we calculate like this? Prefix I dash 1. You can see I dash 1. We will have A times V plus with number I dash 1. Why? In this one, we can see this one as we only calculate the number before index this one. So that's why we have I dash 1. So we will take the first the number before of the before I. We will take the prefix I dash 1. However, in this operation, we haven't have time with the value of I dash 1. See? For example, let me do it right here for you. We will have a prefix one A, and then in this one we will have we need to calculate for this one we will have 2. We will have A equal I, and then we need to calculate this one I and we will have this one So for this one, we will have num 1 equal b. So that means for index 2, we will have equal this one times num 1 no, this is 0 times num 1 because now index 2 we have 1 2 here 1 0 1 2 that's 1. Yes, it's correct. So we will have I B is correct. Okay, perfect. Now we calculate surface. Okay, at this time we will let surface and surface and that's 1 equal 1, similar to like this element is on the right of the last element is empty. For let I plus 2. The reason why we need to calculate on the 2 because you can see here we will have n plus 2. Yes, so it should be until here. It will be stopped here. But the first as the last element we have number I will plus with the last number of num. Okay, so I bigger or equal 0 I dash dash. Surface I equal surface I plus 2. Let me think. No, it shouldn't be dash 2. I plus 1 plus with nine plus 1. Yes, it should be plus 1. Okay. As we dash dash. As we get the difference, yes, we have a difference. We minus here. So the simple way to think is about we need to make sure that this one covers the index 0. Covers the index 0. However, to explain more, I will write here that and here surface here we have a 4 so this means we have 1, 2, 3, 4. This one we have this one 1. Yes. It's the same with the first graphics, but right now we are using reverse it. So, okay, let me try with n equal 5. So, that means the 4 here, surface 3, what will we have? Surface I, surface I, and surface I, at this time it should be 5, that's 2 plus 1. Surface 4. That's 2 plus 1. 4. So that means right. One, 0, 1, 2, 3. That's here. Here. Okay, now we have a breakfast and surface. Now we will answer of I equal result I smaller than n I plus plus answer I equal breakfast I surface I return answer. Okay, perfect. Okay, let me create a test. Okay, I write this one for testing. You see? Okay, and then I run it here. See? Perfect. Okay. Thank you.